still widely used. It's cheap.
How about Yarn? Is that required for it to function, or is that an option?
You can run it on Hadoop 1. You know, without Yarn, you can. But you can run on both. You can run on both. Yeah. Okay. All right. Okay. So, all right. Let me just. So a lot of this stuff could sort of be answered if you just try it, right? And it turns out it's easy to try, and that's a good thing because you know, just getting into Hadoop, it's kind of painful, partly because the documentation isn't great, and there's a lot of quirks and you know all kinds of things like that. But this is as simple as it is. Easy if you want to do it, just download it. And I've done this, you know, I still do it this way. I just go down there, download this jar file, add that to the class path. That's all you need. Literally, that's all you need. One big jar. It's about 126 megabytes today. So it's a big jar, but it's got everything you need. You don't need any other dependencies, nothing. It just works, right? And you can just create an Eclipse project, add that to your class path, and you're good to go, right? If you're a Maven guy, go add that to your Maven POM file. It'll take whatever, you know, it's going to download all this nonsense, and that's what Maven does and whatever. And but it works. It's easy. Okay. So, and also if you're, you know, you want to use the Spark shell, that's a great way interactively. You can run it either in Linux, Mac OS, or in Windows. A lot of times I run on Windows, and as you guys know, Hadoop doesn't really work so well on Windows, but Spark does. Spark works great on Windows. All right. So you can interactively type in like all that little stuff we were doing. You just type it in, and you do get some kind of code completion. You can hit dot, and it will prompt you. And it's not perfect. It's not as great as Eclipse or something like that, but it's better. I wouldn't say it's as good as PySpark. I mean, PySpark or the Spark Interactive shell command line. That's still, you know, but it's pretty good. It's a great way to sort of exercise code, get familiar with it, play with it, that kind of thing, interactively. Okay, so this is what I do I do this very regularly, is just build from source. And some of you have actually built Hadoop from source, you know, I salute you, right? That's great, that's wonderful. I wouldn't even try, because I mean, just to download it, it's massive, it's huge. Hadoop source code is huge. Spark source code is not that big. I mean, it's big, it's not tiny, but it's not that big. So a lot of times you want to build from source, and just about every time I have downloaded and built from source have not had a problem. I don't think there were a couple of times when I had some minor issue on Windows, but even now, even like I did a couple days ago, I literally downloaded the whole thing, you know, just cloned the whole Git repo and just built it, and it built fine. You know, it takes a little bit of time. It takes about a half hour or so. All right. So there's a couple of, so why would you do that? Well, you want to get the new, latest, greatest releases. They're usually on a 3-month release cycle. It's like one quarter. Every quarter they kind of try to come out with a release. So if you want the latest, greatest feature, you can either wait for the release. And lately it's been taking a little bit longer because, you know, there's more features, there are more people. I'll talk a little bit more about that. Some of the challenges that are going on just in the development process. But to build it, there's a couple of ways. You can use SBT, Simple Build Tool, which is, I guess, commonly used in the Scala community. I'm not really, you know, I don't really know that much about it, but I don't know much about Maven either. I just use it. I don't really want to know, actually. So it's kind of like Maven. This is exactly the steps, and this is exactly what I follow. Just download it. If you're on Windows, you have to download SBT. On Linux and Mac OS, they have a shell script which will automatically download it for you, so you don't have to do that. So Windows, just download that. It does require more memory to build, so at the minimum you need what is XMX? It's the heap space. Is that heap space? Max heap space, heap size, yeah. So you got to up that a little bit, 124, that works, or 2 gigs, something like that will work. Just change those settings in that file, clone the repo, cd sparks, SBT assembly, go have a beer, come back, and Spark is done, right? And in non-Windows, since they have an SBT directory with a shell script in there, you can do SBT assembly in it. That's it. They have other builds also, other rules in there also if you want to run the unit tests. There's an SBT Eclipse if you want to build Eclipse projects for the source code. I put some documentation up on the wiki, Spark wiki, to show how to do that. Most of the Spark guys are IDEA. They do everything with IntelliJ. I don't know, it's not my thing. I do more Eclipse. And I've had no problem doing it in Eclipse. I do it all in Eclipse. Right? Okay, so the nice thing, Spark, you can do in Scala, you can do it in Java, you can do it in Python, and sort of pluses and minuses to all of those. And everybody's got their personal favorites, and I really don't care. I'm kind of language agnostic. As long as it works and I don't have to fight it too much, I don't really care. But why would you use each one? Scala is nice because you have the full access. So whatever API is written in Scala, since it's all written in Scala, you get full access to everything that's available, right? And you get the interactive shell, and you get type inference, which are all sort of the nice things of Scala, right? There's a Scala buddies over there. They love it, right? You love that type inference, right? You'll never go back to, no, not at all. Okay, but so, there's just some downsides because, well, it's relatively newer. It's still been around quite a while, Scala has, but it's not sort of mainstream as much as Java or Python. Python, I think, surpassed Java recently in universities or something like that. It's become one of the top languages. So you may not know it, it's changing, right? What's the story with that? I mean, there's still of course, Java 8 changed considerably too. So Java, of course, how many Java people here? Mostly Java? Yeah, everybody, just about. Spark people? Python people? A few people, yeah, a few people, right? So, most people know Java, and it interoperates. Since Scala runs on the JVM, you can, in theory, access just about any Scala object can be accessed through Java. But they do have sort of another layer. There's a Java layer on top of it, and it's not perfect. But of course, it's high performance. It works just as fast as Scala, or even faster in some cases, right? Everybody knows it, and so it's kind of nice. It still lags a little bit because there isn't always an API to access everything you can do in Scala. So I tend to do things more in Scala. So the big downside with it is because you don't have type inference, and the nature of the way Spark is written, they rely heavily on type information. They really take full advantage of sort of all the type information that it gives you. And the consequence of that is I'm a big Java guy. I wrote a Java book. I wrote several Java books. I really like Java and all that. But, it really starts to hurt after a while because you create one of these RDDs, and the type for that RDD is about it's like 75 characters long. It's just big sums, really complicated. Whereas in Scala, it just figures out what the type is, and you don't need to worry about it. So it can be a little bit more difficult. So take that with a grain of salt. So Python, of course, if you're a Python guy, you don't believe in any of this stuff. Types, well, who needs types? What kind of type you have, you'll know when you get it, right? Right? So it's concise, which is great. People love it. It's well established. But, the performance is not necessarily, I'll say lower, right? Why lower, right? Because it depends how much your code is actually compute bound versus how much of it is I/O bound, right? If it's all your problem is I/O bound, doesn't really matter, right? Doesn't really matter at all because you're going to be waiting on disk. But if you have something that's iterative, processing, in memory, you may see lower performance. I hope I'm not offending all our Python friends here, but hey, that's life, right?
With Java 8, does that help a little bit with the verbose syntax?
Yeah, Java 8, yeah, good point, right? Because Java 8, we do have functions. We have, what do they call that? Lambda, right? So yes and no, right? So it simplifies the writing of the function, right? So it's less syntax, but you still have that lack of type inference. So when you create an RDD and you create a variable that points to that RDD, you still have the type for that thing. And it's a big, complicated mess, right? So that's one of the reasons I sort of, even though I'm a Java guy, I kind of tend to avoid it.
How far, in your experience, does that lag in the API support? And is it something that could hurt you, when you're knee deep in the programming?
It's hurt me. Yeah, there are definitely things that I got into, and that's one of the reasons I went to Scala, because I started out purely doing it in Java. And I'd get to, one thing was just the complex types was a problem, and the other problem was, there are certain things I wanted to do that are available in the Scala API, because there are certain objects that come back that really they're Scala objects and they're wrapped into a Java object, okay? And the Scala object actually turns out to be much richer because the Scala API, like the Scala collections are really amazing, right? And the Java collections, everybody, complains, oh yeah, there's all this promise. It's not perfect and all of that. That's true. And the Scala collections are much richer. And so there's a lot more you can do with it. So that's the other reason. So it does lag, and that's a big issue in the development in the community. It's like, oh, we need to add these all the things that are added in Scala. They need to have Java wrappers around it. They need to have Java API on it. They need to have Python, and Python really lags because Python it's harder, right? Because the Java it's the JVM. You can call those objects directly. You just need to make a wrapper around it. But the Python, it's a little more work. Okay, yeah.
How about the Groovy?
Well, Groovy, I haven't heard anybody doing it, but since it's JVM, it should work. Has anybody tried it?
It works.
It works, yeah. Yeah, so there's no reason, right? But do you get type inference with Groovy?
Yeah. I mean, I just do DAF, RDD, and well, actually, no. I mean, I don't know enough about Scala to really answer that. But I mean,
You don't need to type the variables,
Yeah.
right? Yeah.
Okay.
So then, yeah, so you get the benefit. So yeah, if you want to do Groovy, good, whatever works for you. Yeah.
What's the mechanism that Python uses to make the call out to the Scala? Is it Python or what?
I don't know, to be honest with you. I have not looked that deep in it. It might be JNI. I don't really know. Does anybody know? Does anybody look that deep into how the Python? Yeah. Yeah. Go ahead.
There's this project, I think it's Py to Java. Yeah, that's what it's called. It's just a translation library. I think it does it at runtime.
Yeah, right. So it uses JNI or something like that to call?
I don't think so.
No?
It's just a translation runtime library.
Okay. There's some magic going on. Yeah.
Is it Python on JVM?
No, it's Python. It's C Python. I
No.
don't think it's Jython. I don't believe it's Jython. I'm pretty sure it's C Python, right?
Yeah, C Python.
Yeah, it's C Python. Yeah, I don't use the Python API that much for. I'm happy enough with Scala, so I don't. Of course, the other thing I say about the Python is that it goes both ways. Well, the great thing about it is dynamically typed. Well, the not so great thing about it, well, it's dynamically typed, right? So if you like dynamically typed, it's a great advantage. If you don't like dynamic typing, it's terrible. So it's up to you. Although I do a lot of Python too. I really like Python. It's great for hacking text files. It's a great hack language, wonderful language for hacking. Okay. So it's up to you, whatever you feel good with, right? So now, okay, great. You run it locally, wonderful. You got all the basic things working. But then how do you run it in scale? You want to run it on real data, large data. So it works with Hadoop. It works with HDFS. Works with Hive external tables because Hive external tables are just HDFS files. The easiest way, and the way I do it, is I just launch EC2 cluster, Amazon EC2 cluster. And if you go to that directory in Spark, there's an EC2 script. It's a shell script, and tragically, it only works on Linux or Unix because it needs SSH. I imagine if you had MinGW or Cygwin or some other horrible incantation on your Windows box, you might make it work.